Students, welcome back. In this section we are going to discuss about addition of two 32-bit hexadecimal numbers using 8086 microprocessor. You might have learned the concept in theory classes also. Now we'll briefly see how to add two hexadecimal numbers, then how to program it, how to write the program, and then how to execute and see the output of 32-bit addition. Okay, for that we need to learn first what is a decimal number, what is hexadecimal number equivalent. You can see here we have made like decimal and then hexadecimal equivalent. So from 0 to 9, even in the hexadecimal numbers the same 0 to 9. After 9 it is 10, 11, 12, 13, 14, 15 in the case of decimal. In the hexadecimal it is 10 is equivalent to A, 11 is equivalent to B, 12 is equivalent to C, 13 is equivalent to D, 14 is equivalent to E, 15 is equivalent to F. We'll use this and we'll add these two hexadecimal numbers. We have got two hexadecimal numbers 5, 6, 7, 8, 1, 2, 3, 4, and then second one C, D, E, F, A, B, 1, 2. We have to add these two hexadecimal numbers. We'll see how to add this. So 4 plus 2 it is 6, 3 plus 1 is 4. What is B? B is 11. 11 plus 2 it is 13. What is equivalent of 13? It is D. So I have made as D. Then A plus 1, what is A? It is 10 plus 1 11. What is the equivalent of 11? It is B. So I have made B. So this section is completed. Now if there is any carry, I need to carry forward here. Since I don't have carry here, I'll leave this. Then I'll go on to this one. So what is 8 plus F? What is F value? It is 15, right? 15 plus 8, what is the value? You will get 23. Okay, 23 if you divide by 16 it will come 1 7. So 7. Okay, 1 7 you will get. So you will make it 7 here. 1 will be carrying to the next level. Okay, so 7 plus 1 8. 8 plus E, what is E? 14, correct? So 14 plus 8 you will get 22. 14 plus 8 you will get 22. You need to divide this 22 by 16. So you will get as 1 6. So okay, 6 you can put it here and then take 1 to the next level. Okay, what you will get? 6 plus 1 7. 7 plus D. D is 13. So 7 plus 13, what you will get? 20. Okay, 7 plus 3 20. You will get 20. So 7 plus 3 30, 20 you will get. In that 20 divide by 16 and you will get as modulo. You will get once you will get as 4. Okay, 4, and you can carry 1 to the next level. So what is C here? C is 12. 12 plus 5 plus 1, right? 12 plus 5 plus 1 you will get 18. Okay, 18 if you do again you will get 1 2, that is 2 you can put it here and then 1 you can take it to the next level as a carry. Okay, so you must get an output in this way. Okay, so in the microprocessor it will take from the 2 2. Okay, like 4 6 BD and then 6 7. Okay, 2 4 in this way it will take and it will show the output. Okay, we'll see now what is the microprocessor program for writing program for this addition. Now here we have two segments. One is called as data segment. While writing any program it is common to have two segments. One is called as data segment. Okay, the other one is called as code segment. In the data segment we'll declare the input variables and the output variables, whereas in the code segment we'll be giving the actual instruction what to be executed. Right now what is our objective? To add two 32-bit numbers. So since it is 32-bit numbers we are defining as a word. Okay, so number 1 define word. So first number is given here. Similarly number 2 define as word. If it is in the case of 8-bit numbers we'll type it like a dB. Last video we have seen like dB, right? Since it is a 8-bit numbers, it is dB, it is a 32-bit number, so we are taking it as a DW. So two 32-bit numbers we have taken, number 1 and number 2, After that we are having the result. Result is again it is a defining in the terms of word. Okay, and then with this data ends. With this data ends, data segment is over. Next, coming to code segment. In the code segment, this is a common term which you are going to write it for all the programs, like assume CS as the code and DS as the data. And then first one we are main, what is main, you are declaring like main is move AX comma data. Data is to be moved to the accumulator register. Okay, in microprocessor everything should be stored in the memory before moving on to the any sort of registers. Okay, so since we cannot do any operations in the main memory accumulator, we are moving it to sub registers and then doing the operations. Okay, after that code starts from the code segment. Here we need to add two 32-bit numbers, but to store two 32-bit numbers we do not have a 32-bit register in the case of the 8086 microprocessor. We have only maximum of 16-bit register. So what we will do here, so see here we have two 32-bit numbers, correct? So we'll divide this 5678 and CDEFH, this as one segment, and we'll divide this as the other segment. We'll first add this 5678 with CDEFH and then we'll add this 2 and then we'll get it into the registers. We'll get it into the registers. So now the command is like, first we'll move first number to AX register, moving the first number to the AX register, then moving the second number to the BX register. Okay, so default, since we have, what is the first number here? First number is 5678. What is the second number? CDEFH. That is second number. We are moving that to AX and BX registers. So the command for adding two numbers is simple. Add AX comma BX and then your result will be in the AX again. That you are moving it in keeping it in the result as a register. And then now what you are going to do, you are going to take the second number. Okay, you are going to take the second number, and if there is any carry, because since here we are, as we seen, we do not have carry, so no problem. Once if suppose any carry is there in these two numbers, it has to be carry forward to the next segment, and if there is carry in this, it will be there, it should be stored in the flag register, carry flag register. Okay, so for that I am using this move AX number 1 plus 2, move BX number 2 plus 2. Then now I am adding these two using the ADC command. With this ADC command I will be able to add with carry. Carry also will get added and the result will be stored. Now last command is int 21. It is an interrupt command int 21. With this interrupt 21 is a common command which will be used for almost all the programs. With this interrupt command your program will get end. So code ends and then end main. So we have started with main, open main, and then we are ending it to the main, and then we have started with the code segment, so we are ending with the code ends. Okay, with this we are completing the programming part. Okay, this is the programming part. Now we will take it to the executing part. Okay, now what we will do, as we see in the last class, I hope that you have all installed the DOSBox installer with the last class instructions. Now what we will do, we'll directly move on to the DOSBox. Okay, what is the first command? mount // enter. Now what is the next command? Yes, it is C:. Okay, after this what will be the next command? We are going to move to the 8086 folder, CD 8086. Now it is into the 8086 folder. After this what we have to do, we have to see, already I have written a program for this. Okay, we will see that program first. Edit, we go to the edit. Okay, file, open. So I have made it like add 32. I have made already the program, the same program what we have explained here, explained there. It is there. clearly here. Like we are going to take two numbers, okay, number 1, number 2, and the result will be stored in here as the word, defined word here. Result also will be stored here, and then program will code ends end main as we have described already. So now we'll save this. We have saved this, and then we'll exit from this window. Now we'll execute and see masum add 32.asm. What will be the next command? We need to link, since we don't have any errors, 0 warning errors, 0 severe errors. So we will now link it. Link add 32.obj, and then put enter. Okay, then we need to debug. Correct? What is the command? I can just go with .exe if it is a 8-bit. Now it is, since it is 32-bit, we'll go with the debug instruction directly. Debug add 32.exe. Clear? Now we have got it. We will first see the program. Okay, if you put U, you can see where is your program. We need to find out the address of the interrupt. So it starts with 000. Okay, and then you can see here, you can see the int. I cannot move the scroll. Okay, you can see here int will be there. Where is the int? You can see what is int 21 is the interrupt last command, right? Where is it? It is in address 002A. So we need to check from 000 to 002A, correct? So get, G is get is equal to 00000 to 00, what is that, to A, okay, to A. Enter. It has fetched all the values in the registers. Now we'll see the output. For that you need to press D 0000. You press, you'll get the output here. Now I'll show you the actual output, what we have got it. Here is the program. Here is the program. Okay. We will see here. See, now I told you that it will read from the last. Okay. So here you can see that 34 and then 12. You must read like this: 34, 12, 78, 56 is the first input. You can see here 34, 12, 78, 56. So here we have got the first input. Next input is 12, AB, EF, CD. So you can see here 12, AB, EF, CD. So with this our two inputs has got over. Now what will be the output? B, you can see here output. What is the output here? BD 46. Okay, it is 46. BD 672401. Correct. So from here you can see here, what is this? 46 BD 6724010000. So now we can conclude that we got the output. So first 4 are one input, second 4 are next input, the last 8 are your outputs. Okay, 8 combinations are your output. Last one is carry. If you give the input, see, you can try it out with this input. this number 1 number 2 if you can give, then you not